Welcome. I'm Colin Masson, the Research Director for Industrial AI at ARC Advisory Group. And I'm here today with Bryan Saunders, Global Director and Head of IoT Industry Consulting at SAS. Bryan, tell our audience a little bit about your role at SAS before we discuss SAS's approach to the AI and analytics lifecycle.
Sure. Thanks, Colin. So I have the distinct pleasure of managing a diverse group of subject matter experts that reside globally, expertise in various fields, whether that be manufacturing, energy, transportation, oil and gas, healthcare, public sector. We cover a pretty wide range of opportunities for our business. Really, our primary goal, regardless of that field, it's to help customers understand kind of the planning, adoption, and execution of strategic roadmaps for analytics solutions. And so that's sort of our North Star that sort of dictates kind of our day-to-day engagement models.
Let's move on to developing models, the second phase of SAS's AI and analytics lifecycle. And I know I'm beginning to sound like a broken record when I remind ARC's industrial clients that we've been using data science, machine learning, neural nets, reinforcement learning, heuristics, all forms of AI for decades. And every industrial AI use case typically may need a different set of techniques, tools, and training approaches. In other words, pick the right tool for the job, and not to be dismissive of Gen AI, but it's just one more tool in our industrial AI tool set, and it's a pretty expensive tool as well. So how do you approach, when your industrial clients are really looking at which tool to use in that industrial AI tool set? What is your approach? How do you advise them?
Yeah, well, I'm shocked to hear that Gen AI isn't the silver bullet that's going to solve all of our problems moving forward. But no, in all seriousness, we certainly see the power of Gen AI, but we also realize that to your point is just one tool in the toolbox. And so as we start to think about this phase of the analytics lifecycle, where we're kind of moving into that model development loop, it's really trying to drive efficiency and value in the model build, validation, and optimization phases. And I think when most folks hear the term analytics, this is where they naturally align their brains. They go to, oh yeah, I'm going to go do some data analysis. I'm going to create or train a model based on my problem set. But I think that sort of traditional view is also one of the problems. Most folks believe that in order to engage or participate in this phase, you've got to be a developer. You got to be able to program, or a professionally trained data scientist. And I think that's a misnomer. That's a point of emphasis that SAS has invested heavily in technology and solutions to expand the resource pool. I'm a mechanical engineer, not a data scientist. So the goal is to provide access to subject matter experts and what I would maybe call a citizen data scientist. You're sort of a hybrid in between. You've got a little data science chops. You understand some of the basics. But in my view, as a subject matter expert, I shouldn't really care what I'm using. Is it a regression model, neural net, decision tree? It should really be focused on what is the business outcome I'm trying to achieve. And a lot of that complexity needs to be abstracted. And it usually comes down to cost. You mentioned that, you don't have infinite budgets to go. You don't want to train a large language model to do a threshold alert on a pump temperature. That would not be the best use of funds. So it's really coming back to helping customers expand and use a larger percentage of their workforce, freeing up their more skilled users to go after the complex, challenging of problems. I think they see quicker value. They're able to scale up, drive better return on investment. I think probably just the best way to summarize it, and maybe it took me a while to get here, but really there's a continuum of capabilities that really is driven by what data do you have. The data you have may dictate the analytic methods that can be applied. What is the expected outcome? Are you doing anomaly detection? Are you doing a forecast? Are you doing remaining useful life calculations? Obviously, that will also dictate what class of AI is best suited. What is your organizational maturity? Like, if you are just getting started, you probably don't want to put a bunch of neural nets out into your production facilities, for the realization that as an engineer, model interpretability often trumps model accuracy. So if I don't know what the model's telling me, I'm probably not going to do anything with it. So again, I think as complexity goes up, change management and adoption hurdles go up with it. And so I think organizations need to really balance data outcomes and maturity, and more importantly, cost, as you've rightfully highlighted.
Yeah, and it's funny, in another conversation with the chief AI officer, he kind of talked about 80% of their AI deployments, their solutions that they were delivering for customers, were not using Gen AI. We're using narrow AI techniques or algorithms and proven methods, partly because they are almost an order of magnitude cheaper to actually deploy, and they're more accurate. And in many cases, to your point, they're explainable, right? You can actually understand why certain recommendations or inferences are being made. So certainly, but I do love the SAS AI and analytics lifecycle concept. It's very much aligned with ARC's industrial AI use case lifecycle that I included in our vision for industrial grade data fabrics. And as we've already said, no one really has the full vision, right? I've been pretty transparent that, I don't believe there is a one-stop shop or platform that can address the wide range of data type stores and models for all of our use cases for AI end to end across the industrial value chain. But we are seeing people try and assemble them, right? And in a previous conversation, we talked about, your advice that people go after one business outcome, one use case, if you want to call it that, at a time. Can you share some examples of how you're helping realize that vision of one use case at a time, and helping customers, SaaS customers, kind of build out that industrial grade data fabric?
Yeah, so I will. I'm based in Atlanta, so I'm gonna have some bit of a homer here. I'm gonna pick some companies that I work with right in my backyard. But Georgia Pacific, they're one of our key customers, and I would consider them a partner. I think we're on this analytic journey together. For those that don't know Georgia Pacific, they're a world leader in pulp and paper industry. And like many manufacturing organizations back during the COVID era, they were facing challenges, and those challenges were pervasive. They were, how do they maintain critical equipment uptime to meet production demand? How do they maintain the highest levels of quality to reduce waste, protect revenue, keep products on shelves? That was a real problem. And the most recent hurricanes that started to creep back into the hoarding of paper products, and more importantly, to protect the safety of the workforce. They understood that these challenges were not going to be solved using traditional methods. So they wanted to really lean in on analytics. They had certainly invested, but they were struggling with capitalizing on value. They had teams where they, I think, on that last mile of the analytic journey, really tying it back into their business operations. That was a big hurdle for them. They approached it, I think, in the right way. They said, look, we know that this is, we can't eat an elephant at once, one bite at a time kind of mentality. And we said, where is your biggest pain point? Where is the biggest problem? And they're like, well, probably the most consistent problem we have is in our maintenance of our rotating assets, pumps, motors within their facilities. And we have lots of vibration data. We'd love to be able to process that, derive better predictions when these assets could go offline, better planning for our emerging maintenance requirements. So we said, okay, let's start there. Let's just look at vibration data. And again, that was the first building block, their time series data pulling from their OSI Pi investments. Now Aviva Pi, I should clarify that.
Yeah.
And then when we kind of the next problem was, okay, now that we're improving our uptime, we would like to tackle some of the quality challenges, our throughput, the velocity of products that we can generate. How do we optimize set points? And that moved into their quality realm where you needed more of their MES data, et cetera. So you start layering in those other data systems to create a more complete canvas to derive more advanced models. Then the next phase was kind of that worker safety. This became paramount that, well, how do you instrument worker safety? So they were like, well, we have lots of cameras. We would like to monitor movements or folks getting within harm's way of running conveyors and paper machines that could lead to injury. And a lot of that was tied to workforce turnover. You had folks that weren't as knowledgeable. And so they started working through computer vision and other data systems. And so slowly, bite by bite, they were able to sort of build this landscape. And then after they had kind of run a project through all of those disciplines, the next project was just so much easier because they already had that foundation in place. And they do I think in terms of model development, they're a bit of an anomaly, in my opinion. You can tell they weren't like hardcore data scientists that created this group because their mantra is good enough. Now, most data scientists never say good is good enough. Pursuit of perfection is really their North Star. But they said, look, we want to put something into production that makes us incrementally better today than we were yesterday. And we're going to learn and we're going to improve and we're going to update that model. And so the day after, we're better than we were today. And so they have that day by day mentality, that relentless pursuit of value. Kind of another example is from a adjacent transportation industry. We work with Lockheed Martin. So Lockheed Martin has C-130J aircraft, transport humanitarian aid type aircraft. And they supply these to government entities across the globe. And there's quite a bit of data challenge. So we started with them purely on better data integration, better data management, and cleansing. Because they were paying a lot of folks to do that work. And then they're like, okay, now that we have our data done, now we'd like to start doing spare parts forecasting and optimization. When we send these aircraft out for missions, how do we better prepare our customer with the right set of spares? And then they move into intelligent diagnostics. So now once the mission's complete, can you learn from the data coming off the aircraft to more quickly identify emerging maintenance needs and prioritize a corrective action plan? And so again, each use case sort of built them kind of that next layer of the data fabric. And I think they have achieved significant successes within their enterprise.
Thanks for those great customer examples, Bryan. And I actually know Mike Carroll and the GP team pretty well, and in fact, I'm hosting a leadership summit with them because I think they're such a great example. So that one certainly resonated with me. Mm-hmm. Thanks. You've been listening to Colin Masson of ARC and Bryan Saunders of SAS discussing the AI and analytics lifecycle. For more on today's topic, download my ARC view titled Industrial Grade AI, Transforming Data into Insights and Outcomes from arcweb.com, or follow Bryan Saunders and I on LinkedIn, where you'll find transcripts of today's conversation online and links to that white paper. So thanks very much for listening to us today.